I have a lot of sort of philosophy and ideas about how we can work together. And I wanted to try and encourage us to do that a little bit more and to sort of allow for folks to build off of each other. And that's actually what I'm kind of all about, and what I've sort of learned as I've been interacting with this space myself. I got into this sort of thing way back when I was doing security assessments of all sorts of different platforms. And I really got interested in the idea that you could put millions of dollars and many man-years of effort into securing a thing, and one little problem could just destroy it all. It all comes crashing down, and those problems tended to be at this firmware and hardware layer. And so I got super interested in that, and that's how I ended up eventually at Intel handling updates for firmware stuff. Met a lot of you folks there, and now at Eclipsium, trying to sort of put something together in the ecosystem as a product that an end user customer can start to deploy to sort of handle these things. And what I'm going to talk about is a little bit about, well, I call it, I sort of look at this space as having the tragedy of the commons problem. And the tragedy of the commons is this idea that, you know, I'm looking at you to solve it and you're looking at me to solve it, and nobody's going to actually do anything. And this is actually what I read from, or sort of how I interpret some of the things that people have said all morning. All of these different areas and different specific instances of this tragedy of the commons where everybody kind of knows this needs to happen and nobody's doing it. And that is almost something you can expect from an industry and in a relationship of different parts, the supply chain, if you will, that is as big and as complicated as it is, given that we all have to sort of do our day jobs, which probably isn't this. And so we are in a situation where the current state of affairs is that most systems will have vulnerabilities that you know about, that you can assess, that you can specifically name, and I know some of the talks earlier today actually mentioned. So I feel like it's really more a matter of how do we deal with these things? Well, one way is just to even look, just as examples, at, you know, how many different drivers, and I know this is very similar to what Alex mentioned earlier. Yeah, how many different drivers are allowing us to bypass OS security mechanisms and get directly at some of these hardware and firmware interfaces? How many different systems are not configured to actually lock down those hardware and firmware interfaces? What is it that we can do to try and bring this back to a place where we're improving, where we're getting better, where we're actually capable of locking things down? So I'm really pushing all of the problems out of this talk just because, well, really because of the time. But I'm going to really focus on what I think we could do if we work together. And so if you look around at what different folks are doing that is kind of successful, this idea of being real time, being automated, being not having the answer from the beginning, I think is a very important idea that we probably can build into what we're doing. A lot of these systems and some of the things that we've talked about earlier today are built on this root of trust and this idea that there is a thing and I trust it, and based on that thing, I can verify everything else. Cool. That is a very strong, very powerful mechanism, but as soon as that one thing fails, everything comes crashing down. And if you look at things like, Brian was talking about 800.193 and the concept of recovery or the concept of resiliency, the whole idea is that if one thing fails and everything comes crashing down, well, maybe that's not what we want. That's probably not the kind of robust system we're looking for. And if you look at some of the methods that we use in, say, DevOps, we really don't expect that we're going to get it right the first time. And that's probably a good expectation. So in firmware, in hardware, how can we sort of leverage that same sort of expectation? And I think we can. I think it's not just a matter of hardware is immutable, there's nothing you can do about it, because we've got plenty of firmware. We're doing all sorts of things to configure that hardware, and there's all sorts of knobs and switches that do exist. That's what we're getting wrong. So in fact, there is probably a way, if we apply sort of the same real-time, automated, quick deployment rings, this concepts that are used in DevOps, which now becomes DevSecOps, we can use these things to actually try out and make changes in production on systems in a way that will actually matter, whether it's updates, like Brian was talking about, whether it's finding vulnerabilities, like we've been talking about before, or maybe it's actually just visibility. And so this is where I think it gets really interesting. You can look at identification of what you have, at the configuration of what you have, at the behaviors of what you have, and you can start building this telemetry. And that's all about visibility. It's really a security problem, and we are actually trying to tackle it, but we can take all of these visibility metrics and actually create the continuous improvement lifecycle that we're going after using that. So what's necessary in order to make that take place? We have to work together. We have to be able to build on top of each other. If we build some piece of hardware and we have some root of trust and we have some stuff, cool. What is it that I can look at that tells you that that's there, that it's correct, and maybe what version is, that sort of thing, how it's configured. But how then can I take that and build something on top of it that works with it to enforce policies, to enforce new policies that you hadn't thought of before, to observe or measure things that weren't part of that original maybe root of trust? How can I extend it? How can I add these other peripherals to it? And similarly, there's been this concept, and it gets into these ideas of updates. How do I define and know where trusted sources of firmware are, or trusted sources of those measurements, that telemetry? This idea of how do I know what's right when I see it? And this is where I'm not just coming up with random ideas and throwing them out there to a bunch of people. These are ideas that are actually in progress, being tried, and we're sort of toying with them already in some of these open source projects and in some of our products. When we are building things in using these common libraries, just like Brian was talking about, and you can use Tiano Core as an example, but you can also use Core Boot, and you can also use some of these other Linux boot type projects where you are establishing a single place where you can sort of make the change, try something new, start deploying. You're actually looking at collecting measurements and updates together in projects like LVFS. This is also what Microsoft is doing. This is actually what other companies are doing when they try to manage the firmware ecosystem and the updates associated with it. Those things are essential pieces, but they have to be connected into not only the repository of the code, but also into what the end user actually sees. This often comes in the form of security advisories, which are these dense things that people don't like to read, which in fact should be part of the customer's deployment process, the customer's DevOps, the customer's IT department. And if we can make that more accessible to them, which sometimes we do in the form of things like chipsec or the host-based firmware analysis framework. And those things are great, but they're not really directed at the right audience. They're directed at the developer. We can actually expose these things to end users, and we can publish these things both through these official repositories, but also through the user interfaces, through the things that an IT department would actually see in order to know which systems to go do something about and what to do. And so I think that's where we're headed. I think we can leverage a lot of this common ground that we have and work together, and that's sort of what I'm proposing and what I'd like to sort of see happen. I will be around afterward. I'm going to sort of conclude here. But I will be around afterwards just to talk about that and how we can incorporate some of these things together and work together to actually make some of these things a reality. So I can answer questions for a bit, but up to you guys. Thanks.
Yeah. I actually have one quick question. So there's a few efforts on continuous integration for the upstream Linux kernel, the embedded Yocto community. There's been a few summits this year. I think it would be useful to propose to those folks who are trying to share test results across different hardware that they collect hardware level data, and
that stuff,
and standardize it in the schema for the kernel.
That's exactly the sort of thing I'm talking about, and that's and I see what you're saying there as this is something we inherently want to do already. Those projects already want to do it. Mm-hmm. We need to put it in a way that we can actually put it together and have other people build on top of it. Yep. Which is, in a sense, this is the point of ChipSec, for example, is to have a common framework for testing vulnerabilities at this layer. I think if you have test results from things like HBFA, this is also very useful. You can pull these things together into a common place.
Yeah. So there's a few conferences coming up in the next few months where Red Hat's conference for the upstream kernel would be a great place to pitch these ideas.
Totally.
Yeah, so that's a conversation Richard Hughes and I have had a lot about LVFS, and it turns out over the past 6 months, he started collecting and publishing more of this type of data because LVFS has a different problem of trust than the Microsoft Windows Update. LVFS is, literally a guy in a shed. He works out of a shed off the back of his house. So how do you trust that infrastructure? And the way you do it is by putting out more data about what is inside the update. So the manufacturers don't just put the update up. They also publish things like, here's chipsec log, or here's other information I could provide, PCR measurements, for instance, that say here's once you download this thing, here's other things you can do to verify. So you're not just trusting the source of the information. You've also been given more data by that source that you can use to compare. Like if he says, oh, this is supposed to be PCR 0, and you download it and it's not one of the PCR 0 values associated with that platform, you raise a flag. Now you have a way of saying this wasn't what I was expecting, or a way of validating, kind of like a mega CRC essentially, that this is what I was expecting and here's the level of work that's been done to inspect it.
Trust but verify. No, it's exactly what I'm talking about there. And the idea is that even if one thing fails, you have this backup. You have reasons to trust the repository. And he does actually pull in things like chipsec logs or whatever they will give him as part of that trust relationship. And there's a signing process. Great. But there is also supposed to be this verification process that says even if that for some reason was broken, I have some way of detecting and something I can do about it. I think that's important, and that's what I think we want to be doing at all these different levels.
Is LVFS moving to the Linux Foundation?
It is.
It is? So I think the kernel CKI is also moving to the Linux Foundation. So they're all going to be under the same umbrella.
So you're talking about getting visibility into the system after the firmware's on it. How, right? There's some parts you can see from the OS level, but there's a lot of parts that, what kind of visibility can you actually get into them? And what do you think you need that doesn't exist now in order to get that visibility that you want?
That's a great question. And I like that you both pointed out the thing that's probably going to be broken. And yeah, there's going to be stuff we can't see, and that's a problem. And then there's also we're talking to a group of people who might be able to have some influence on that problem, and now is a great opportunity to do that. Thank you. The reality is, if we don't have visibility into your thing, then we can't do that verification step that we were just talking about with Brian. That thing only happens if there's something I can look at, if there's something I can know is right. And I don't even necessarily have to have the perfect authoritative answer of what right is. But I can say that this is anomalous, everything else looks like that. At least let me do that. But if you give me nothing, if I don't have an interface to extract, if I don't have a hash, if I don't have anything to work with, you're going to force us into a situation where we're going to do security research and reverse engineering and some sort of a mashup of whatever we can see, which might be stupid things like timing measurements. Maybe they're not stupid. Maybe that's really good. But it's super hard, and we can make this a lot easier. So what I'm looking for, to answer your question, is known good in at least the form of here's what the firmware should be. But best would be here's what the firmware should be, and here's how you can check it again at runtime. Here's what you should look for in the way of behaviors about the firmware, even if you don't let me extract it. Here's what you should look for in the form of behaviors about the device, about how it interoperates and what sort of responses I should expect and what sort of, maybe even timing, I should be expecting for those responses. Does that make sense? I think it's not necessarily one answer. You can come up with new things there, but the idea is tell me what to look for to know that the device or the firmware or that stack of stuff is actually operating properly. All right, sounds like it's lunchtime.